Yay!
Hey, here we are, and we're
Hi,
live.
everyone.
I'm
Sorry.
so sorry. Technical difficulties.
Yeah.
OBS decided it did not want to play at all.
I cannot tell you everything, but I saw a chicken running behind JT.
It's not true. There were no chickens. Hello,
You have
everyone.
no proof against me.
Welcome, welcome, welcome. So many of you would have seen the what's the word? I guess the theme of the today, which is building a
Yes, you have
3D
a
printer from
theme.
scratch. Now, we happen to
Yes.
have the wizard at such things with us, which is rather handy. And this may be a multi-part series. Oh, hello. Oh, we're
I'm
playing
trying to adjust my color.
your color. Okay,
Live.
nice. Ooh, how cool of you. Yeah, that's actually not
Yeah,
terrible.
not bad.
Because you're not
It was too
you're not
yellow.
normally that yellow, are you?
I don't think so. Nobody told me that.
Okay,
Like,
that's
you are
actually
too
quite
yellow
good.
today.
I
That
like it.
never happened. Yeah,
What do
that's
we reckon?
some liver
Does,
illness.
does Ivan look good like this, or do we like him yellow, jaundiced?
I can yellow myself.
No, leave it like that. He's not SpongeBob, correct, Jeff?
I'm in peach color.
Yeah.
Yeah.
Yes, correct.
Yeah.
Alrighty. So, do you want to take it away, or shall we talk about a particular printer?
Yeah, we should talk about that printer
All right.
because
Now,
it's so on topic.
yeah,
So we
it
have to.
absolutely is.
Yeah.
I'm gonna just switch something quickly. I know you guys can see the things. Let me
I
move
have a
that.
notepad in my face.
Yeah, that's all right. We'll get there. We'll get there.
Yeah.
So, Tetra 3D Print happens to be in the chat, which is very lovely. Hello, hello. Yes, there we go. And talking about building 3D printers, some maniac built 64%, I believe it was 64%, correct me if I'm wrong, scaled version of a Prusa. Now,
Yes.
there was a little bit of chatter on Twitter about whether or not it was an actual Prusa machine. Oh, yeah, 64 is right, terrific. Whether Joe Prusa had done it himself, or whether it was a gimmick, whether it was a purchasable thing, and it turns out that Tetra 3D Print decided to build it.
Confirm is 64%.
Yep,
Yes.
lovely, good.
Yeah. Like I have to ask him, have we met? Because your face rings a bell.
Oh, that's not what I want.
I need to know.
Sorry.
Have we ever met? Yeah. Intro. Yeah. I'd really like to know. Yeah.
Because you recognize the face, yes?
Yeah, that face. Yeah. And Brian is, yeah.
Oh, man.
No.
There you go.
And you told me, JT, you lied to me.
I
you
did
told
lie
me
to
he's
you.
using the same
Yes.
motors.
And
he's using very rightfully NEMA 11 motors.
yes.
It has to be so cute. I want one.
I apologize. Yeah. I do apologize. Before we came on air, Ivan said, I'd rather build something small for a change, and this is such a fantastic thing.
Yeah, because I'm losing my mind. Yeah, because I got myself into another huge project, and I kind of like, yeah.
What? You don't do huge projects. You just hit print and walk away and come back tomorrow, and it's done.
Yeah.
All right, many tomorrows.
Make 3D print bits or something. There is a guy that puts a lot of names in a tweet and asks a question.
Oh, yes.
Not to me, but someone always retweets it.
Yep.
And he asked if anyone prints anything that has, if anyone has ever printed something that is as large as the print bed, one part. And I said I hardly ever do otherwise. So yeah.
Yeah, absolutely. Yeah.
It's a big project indeed. But if you need to print a part for that project, it takes little.
Oh yeah.
Yeah.
Unlike the thousands of hours for a particular project you're currently working on.
Oh yeah. Yeah. We are now at 4,500 hours
Oh my god.
and counting. Because I don't know if you can hear them, but the printers are now printing.
No, I cannot hear.
No.
Therefore,
No.
everything is good.
Yes.
Uh,
So, how is the name of the person behind Tetra 3D print?
I actually don't know the
Is
human
Mike?
name.
Is Joe? Is
I'm going to go with Fred.
Perseo? Mm, Jimmy?
David. He's Welsh.
David? David?
Yeah, it must be Welsh.
Welsh?
Yes, I would imagine.
Is that Welsh?
There you go.
Welsh?
There, he's even written David in
A
Welsh.
Welsh, a Welsh person is from Wales?
Wales. Yep.
Wales. This past week, I met the guy that crossed Wales in a straight line.
On foot?
Yes,
Really?
the crazy guy. Yeah. He has a YouTube channel. His name, I think, is Matt, but his YouTube channel is named Geo Wizard, Geo Wizard, and you should all check it out. This is insane. Welsh, his largest deviation was, I think, like around 20 meters, something like that.
Really? Okay.
Good,
So,
yeah.
so accurate GPS, of course.
I'm betting.
Or lots of thorn bushes that he just couldn't get over.
Everything of everything. It's like his Wales. It has its size. Yeah. So David sounds a lot like David in Spanish.
It is.
Yeah.
Well, it's David. So.
Yeah. David will be able to chip in and gives us a lot of feedback on what we are going to say today, at least today.
Of course.
So yeah.
Part 1.
Should we start?
Of course.
Because the theme is how to let's say like how to build a 3D printer from scratch. And the first thing that I'd say when anyone is trying to build his own 3D printer, you have to set your own specifications at the beginning. What I mean is, what do you want to print with that printer? Do you want to print with clay? Do you want to print large things, small things? Do you want it to be very precise, or do you want it to be very fast? Usually, there is a trade-off. What's your budget? Because that will change things very radically. So let's start by talking about the configuration of the printer. For example, you can choose, like David did, Prusa style printer, and there are pros and cons. For example, if you have a Prusa style printer, you have to take into account that the bed has to move. The bed, entire mass of the bed, heating elements of the bed, and whatever you print on top. People tend to forget about what's on top. But if you make a large printer with a, for example, 4-kilogram bed, which is pretty hefty, could be like 400 millimeter by 400 millimeter bed, and you print another 4-kilogram part on top of it, at the end of the print, the printer has to be able to still move the 8 kilograms back and forth.
Yep.
So and you have a lot of top inertia in the bed. So the part on top of it could be still tipping the bed. So the mechanics of the machine are really important. Did I say periodically?
That's right.
Brian! I got distracted.
Yeah.
So for example, as I told to JT, I need to build a new machine now, a new very big machine now. I'm not even sure if I'm going to put it to good use, but I'm going to build a new machine. So I need to print very large parts that have quite a smooth surface and are pretty flat. So I need a large bed, and I don't need that much height.
Understood.
So there is a trade-off.
Yep.
I could go for a Delta machine, but I would have to make it really wide for it to be of good use. So I've gone for the Prusa style trusting that what the guys at G-Create do is possible.
Okay, so
Because they have,
is it length or you need square? I
I
know
need square.
you need a square, but you don't need a cube.
I
You
don't need a cube.
you do
I
okay.
have, I have, I have my specifications
Mm-hmm.
are almost 1 meter by 1 meter on bed size
Yes.
and around 400 millimeters in height,
Okay.
maybe a little bit less.
Yep.
Uh, so I've decided to go in a Prusa style configuration. I will have an insanely large bed going back and forth. And I have to take into account how much weight each one of the motors with its gear can move. And I also had kind of like I have made the decision that my parts are going to take a long time to print because of the accelerations. So yeah, if you were to print something that has that big of a bed and also prints very tall things, you will get into that point where you are accelerating a very tall part, and it's bringing a lot of torque by momentum of the part to the bed, and that's not that good of a decision.
Okay. Well,
I know that
go on. Go
ahead. Now, I was saying that the G-Create machines are usually very wide, not that long. The bed is wider than it is long, but I haven't seen, apart from having to have a really huge machine, I haven't seen any drawbacks about swapping length for width.
Okay.
Apart from having to have almost double the length in the mechanical parts than the length that the bed has to move.
All right. So
we are talking about almost a 2 meter long machine.
yeah. Well, Adam Bradley has correctly pointed out that a Core XY machine might serve you better in that there's no mass that's moving. It's just the head.
Yes.
You
Yes.
have a
Correct.
rigid frame. You're just moving the entire bed mechanism up and down accordingly.
Yes.
You've obviously discounted that for a reason. Because
Yeah.
you wouldn't be here talking about a Prusa style machine if you hadn't already discounted Core XY.
Uh, is not the correct, like, because if you think about Core XY, you are thinking about, I think it's called a Darwin style machine. Darwin or because there are two, Darwin and Marlin, I think. But the one that is simply a cube with the printing mechanism.
Exactly. Yeah.
The XY mechanism on top and lowering up and down the bed.
Yep.
The thing is that I will be making a very complex mechanism for the Z-axis movement for a very, very, very heavy bed for a very slow race. It will be only like this 400 millimeters.
Yeah. But
So
you could have double, triple, quadruple lead screws, surely.
Yeah, but if you have quadruple lead screws, you know what happens.
Yeah.
You have at least, you may try to find a belt that is 4 meters long,
Yep.
closed, which is pretty expensive and hard to find.
Yep.
Or you could try to synchronize the 4 motors with a different mechanism, maybe rods and angle gears, or 90 degrees gears, and some kind of. But it gets pretty complex pretty fast.
Okay.
You could go with a Prusa style machine using more of the same parts that CR10 has, which is more or less what I'm going to do.
Okay.
So if you are moving a 400 by 400 or 300 by 300 millimeter bed with one motor, if you use 8 times the bed, you can use 8 times the motors.
Sure.
And weight-wise, you will be fine. But raising and lowering a bed gets ugly really fast when you have more than one screw. So it's not a bad idea, but I even would rather be moving the entire XY movement system than lowering and raising and lowering the bed.
Okay, cool.
Because it weighs less.
Yep. So 3D Guzners already pointed out that FunKing 3D has made a very large, so over a meter wide, CR10. We'll call it a CR10, all right?
Yeah.
But it's not a meter square. Also, Ron the Happy Extruder has made what he called the Gigantor,
Yeah.
which is also CR10 extended in one direction only. I think it's 400 by either 800 or 1,000. I've got some links for
Yeah.
that, which I can pull out for you because I didn't
Hmm.
actually know you were going to be building a hybrid such as this. Um, uh, Ron the Happy Extruder typically goes tall because he's making
Hmm.
props or he wants to do a statue or something like that. So
Yes.
he gets extended just extrusion,
Yes.
longer lead screws, longer
Yes.
cables, and that's it. Oh, and the firmware, of
Yeah.
course.
Yeah.
Um,
What I'm probably gonna make is disassemble one of the CR10s or Tevo tornadoes that I have
yep,
broken in there. Use the hardware bits for the Z axis, and the Y axis is going to be just maybe several hardwares of regular beds of CRT machines with multiple long belts.
right, okay.
I don't know if I'm going to put an axle through all the belts because it has been shown that those will self-align every time you switch off the motors. If you disable the motors and you have several belts applying to the same bed, even if one of those previously did lose a step, all will synchronize again when all the motors are disabled.
Okay.
So 4 motors, 4 belts, or maybe 4 motors, 2 belts, it's pretty easily achievable. One thing that I need to have in mind is that the accelerations have to be very low, and in any jerk movement is going to be a pain in the ass.
Oh,
That I will have to be very careful.
the printer's going to slide off the table. It won't.
You
I understand it won't.
you meant that the printer is going to unbolt itself from the floor.
Yeah. Oh, yes, yes. That's exactly what I meant.
It's the is
Yes.
the bigger printer.
So Adam Bradley's also asking, will the bed be heated?
The bed will be, so there will be a bed, and there will be an interchangeable platform on top of it that can be a heated bed or how do you call it in DM wood? How do you say? Particle board wood
Oh, yeah, yeah.
with Captain on top of it, and because I want to have two approaches. One of them is having a huge heated bed and praying for it to not warp. I'm not trusting that. Or I've seen this many times. Putting a particle board, wood board on top of it, putting Captain on top of it, laying a very thick first layer, and then screw that layer to the board.
Really?
Yes, it works.
Okay. So you're
It counts on you being there for the first 3 hours of printing, but yes,
yeah,
it
yeah.
works.
I think the term you were looking for in English is MDF.
MDF,
MDF.
yes,
Okay, good, good. That's fine,
yes.
as long as we
Because
all
in
know.
Spanish is the M, but I don't know
Yep,
why.
yep.
Yeah.
Yeah. Density medium
Medium
because it's
density.
medium
Oh,
density fiberboard.
yeah,
So I'm
yeah,
assuming it'll
then
be
yeah,
the equivalent.
densidad media. Yeah,
Yep.
in Spanish. Yeah, yeah, yeah. That's a valid use case for a rough. And if it is well tuned, it could be what saves the print because the tensions that a very large part applies to the adhesion to the bed are too large, and a screw is never gonna get loose. The adhesion between layers could be uh, decisive for this kind of application, but yes.
So would you actually model a countersink into the first layer or a hole
No, I
for the
will
screw, or
add
you go literally
no.
just
You
straight
add
in?
a huge brim. You add a huge brim to the part,
Ah, okay.
and the screw it everywhere.
Ah,
That's
okay.
it.
Oh, so screw the brim, not the part.
Yes.
Ah,
No, the
okay.
brim. Yeah.
That was
Because
unclear.
then you
I thought you were going
just
to go
remove
into
the
your
brim.
first layer, and I'm going, well, that's not very clever.
No, and what I need to print will require 100% supports on all the surface of the part.
Okay.
So none of the part will be removed from nothing in contact with the bed. So I don't really care what the surface is.
Okay.
Hence, I don't mind to put a 1 mm first layer to absorb all the misalignments of the bed because it's not going to be level no matter
Yep.
what.
Okay.
And yeah.
And that answers Adam's next question. What layer
Not
height are
really,
you aiming for?
because the first layer can be one
Oh, of
millimeter or one
course,
millimeter and a half.
yes. But you're not going
But
to do point 0.2 when you're talking a
no,
meter square by
I
400.
will I will do point two.
Really?
I'm aiming to do point two or even trying to do point one and aiming for 2 week prints, something like that.
A 2 week print.
Yeah.
Lovely. Excellent.
So I might need even to introduce a kind of a UPS into the printer.
Tesla
Because
Powerwall. I can see it now.
yeah. Well, depending on if I use a heated bed or not, it could not even be necessary like that much power.
Sure. Yeah, yeah.
It would be the same or even less than a 010.
Yeah. No, that makes sense.
Yeah.
And you could
With
put
a
it in. Imagine the size of the enclosure that you would need. Yeah, a little
I could,
tent. There we go. Hello.
I could put it. I
You
could
could,
put it inside here. Yes.
all
Yeah.
right. See you, Brian.
Yeah. Then in the winter, I might even need to use, instead of a cooling fan, a heating fan
Yes. Oh,
to preheat the part before the next layer.
last week I said I'll find that little container. There we go. Thermostats.
Yeah, there it is.
Yes. So you.
The entire week you are being looking for that.
No, it was on my desk in front of me.
Yeah.
Okay, so a meter
So
by a meter by
yeah,
400.
yeah.
What, 20 40? 30 60, 40 80. How big is this thing?
I will try to go with 2020 for the challenge.
2020.
Yeah, but I might need to go a little bit berserk with the design of the structure.
Okay.
Because rigidity, if you are using only one beam, rigidity comes from basically the size of the beam. But if you can allow yourself to do a rigid structure made of triangles, you can go a little bit crazier with because the bed is gonna need to have several 2020s in parallel just to make the sliders for the bed, and all of that adds rigidity.
Now, you talked about belts before, so you're going to use pulleys or linear rails for the Y?
For the Y, I'm going to use
Or
nylon wheels on
V wheels, yeah.
V-slot
Yep.
wheels, yes.
Hmm.
But many more than in a regular 3D
Of
printer.
course, yep.
And the first time that I saw a CR10, the first thing that I thought is this is going to last a week. It's plastic against metal. This is not going to last.
And what happened?
I have many million miles on my printers.
Yeah, exactly.
Going back and forth, and they kind of lose a little bit of material where they are really in contact with the metal. But once that happens, they work like forever. It's insane. So yeah. Hey, Motorhead Mitch. I'm really reading your greetings.
Yeah,
right?
I was going to say you're
Yeah.
reading
Yeah.
now. Today
So-
you're seeing what I see.
Yeah, and the basically structure like Prusa 400 millimeters in height, double lead screw for the Z axis.
Hmm.
I'm really curious if to see if I can pull an entire meter of bricks X axis with only one screw on one side.
No, no.
It would bend like crazy.
Yeah, no, I don't think so.
And this will probably require like double Z-axis switch also to do the humming of the entire setup.
All right, here's the next one. You know how we had that conversation about bed leveling and ABL?
Yes.
You're
Yes.
going to do this manual
Yes.
on a meter by a meter.
Yes.
Okay. I wish you luck.
No, I'm not only going to do it manually, but a few years ago I saw there is this thing I cannot remember the name, but there is a box that woodworkers use, which is basically a flat box, and they showed how to make a very thick box that is completely flat on top. It is not twisted, it's not bent, and they showed the process.
Okay.
And it is basically if you have flat sides that is given by flat panels on the sides, and you put two cross strings from corner to corner, at the moment where you see that in the middle the strings barely touch, then it is level. And by level, I mean not twisted, which would be the misalignment that is harder to remove.
Yeah.
And once I have that, I will have that plane with 3 screws, only 3 screws, because
Yeah. Triangle. Yeah. Understand.
triangle, and I will level the bed with those 3 screws.
Okay.
And a very, very thick first layer.
Yes.
And this is when thinking about what you need to print with your printer comes handy, because if you know that you will never need a first layer that is perfect, a perfect laminate that is 0.2 millimeters thick, then you can avoid the trouble of getting a bed that is perfectly level, which is
So back to where you were talking about a brim before. Would that also be raft or no raft?
I don't need any of the parts of the bottom part of the part, the bottom of the part be in touch with the bed. There is no need for consideration. It will go brim straight to supports.
Okay. Oh, so I see. All right. Okay.
Yeah. So yes, and with thicker layer lines, it's not that big bash lift as if manual leveling gets easier with thicker layer lines. It's not that it gets easier, but if you have a misalignment that is, for example, 0.5 millimeter, and you have a 1 millimeter thick layer, you can go straight with your 1 millimeter thick layer, and in some parts of the bed is going to be 0.5, and in other parts of the bed is going to be 0.1. But when you are finished with that first layer, the entire layer will be level.
Just a little bit more squish on some of them.
Yeah, it will squish more on some areas and less in others. Yeah. What?
I don't understand. I'm still beautiful.
This is, yeah. You are always beautiful.
Thank you.
Yeah.
That's so mean, Wellbot. You're missing out on all JT's beauty. I don't understand. I missed something.
So yeah, having a delta setup wasn't even into my considerations because I've never made one, and whenever I've seen one, those seem awfully complicated to diagnostic. Like if something goes wrong, I feel like it is pretty hard to know where that wrongness comes from. So yeah, JT, you can talk to people. They are watching the stream.
Yeah, I know, but I don't want to talk over you.
Why not?
No.
I do it on top of you all the time.
Yeah, I know, but it's
you
all right.
Be rude as I am.
It's a reference to Kathy giving me a kiss. Okay, right. Now I understand. Gotcha. We have someone from Brisbane coming to Melbourne this weekend. Kathy on Twitter, Spud01AU or SpudAU01. I can't quite remember. G'day, Jim. Yes. So it was about me being a beautiful human or something.
And well, about David 3D printer, I have in my list of projects that I probably will never do because I have many projects in my list, is to make a 3D printer that is entirely 3D printed. Like 3D printing the chassis of a 3D printer entirely, and just add mechanical and electronics parts and make it work. Which I still think it's feasible. I even have a kind of a stripped down 3D model in my Fusion 360 library.
Well, John Mack, who's in the chat, has done at least extrusions. He's done some other components as well of 3D printer. How far would you go? Because Wellbot's right. Walter did the same with extrusion. Of course.
Walter did the same. But I'm talking about picking the printer from the bed, adding the 8mm rods on it, screwing the motors, and good to go.
Okay.
Because I think that from a CR10 you can get something like a Prusa, like the volume of a Prusa from a CR10. But one printer, like the entire structure of the around the bed, the arch that makes the z-axis, and all the z-axis rods clip on,
You
all
mean
the
print? You mean
y-axis
print
rods
in
clip on.
place? You're talking about a single print that has
Yes,
everything. So a print in
yes,
place printer, as opposed
yes,
to 3D printed parts that you then put together.
yes.
Aha, that's a job for
And I
Fab 365, I reckon.
why?
They do the print in place fold up
Ah,
models and the
oh yeah,
robots and the
yeah.
whatever. Yeah.
Yeah, yeah, yeah. But I was thinking about that, and then the entire bridge, the x-axis assembly as
Yeah,
another
yeah,
print,
yeah.
and everything clip on.
Which is why you need supports, of course. So will you have?
No,
Well, if you're doing, are you going to do a bridge two or three? Ah, arch. Okay, all right. Okay, okay.
yeah, I think I could do it.
Um, who is anyone in the chat? Was it someone in the chat that I was speaking to about um, reinforcing a TPU GT2 belt with wire or some form of carbon fiber? I had this.
GT2 belts are
Yeah, but
the
I'm
good GT2 belts are reinforced with steel wire inside.
correct.
The good ones.
I was having a
The
chat about printing
chain
one, but
about printing one.
printing one out of TPU, but
I
every X layer
oh
put in the wire, the reinforcement.
okay. You know that there are three FDM 3D printers that have a feed for a carbon fiber thread, and the carbon fiber thread comes straight out of the extruder.
I haven't. I
So you
haven't
have
seen
a
it,
one
but
continuous layer of lay. You lay as long as you are printing, you lay down carbon fiber fiber,
because
carbon
one
fiber fiber.
there was a gentleman at Murph who actually had 3D printed his own belts as well as um, a lot of the cogs. So the interaction between what was it? He actually printed some cogs. It must have been for the Z. It must have been for the lead screw somehow. I can't remember if he actually printed that. Oh,
Uh,
it was rack and pinion. I think he did rack and
I've been
pinion.
I've been printing with pinions, helicoidal pinions on my old Ratman 3.1 for like a year.
Okay.
ABS helical printed gears,
Yep.
and those were amazing. Never broke, never. Yes.
Only be better with PC. Polycarbonate. Sorry, I was thinking that was a Mac PC question, Spike. Sure, why not? See you, Adam.
PC for what?
Maybe the in the belt
Oh, okay.
as reinforcement.
But polycarbonate is not flexible.
Flexible. This is part of the challenge.
Oh, okay.
Yep.
Okay.
Yep. Yep.
Okay. Yeah.
Do-do-do-do.
98 Adam.
Yep.
GT2
Yes.
pulleys and belts.
Yeah, this is the one I saw at Murph, which Mr. Buttram is saying Tom's TCT video showed that printer. It was orange and blue, and orange and blue, red and blue, from memory. But anyway, all right. See you, John Mack.
They are not going to stop until someone prints an SD card,
Yeah,
like the electronics of the SD card or something,
yeah.
or makes cards like the old
80 column card, punch card.
yeah, like putting a lot of cards in, and the printer
Yeah.
picking the cards and printing with them. Yeah, that would be nice.
That's how you upgrade your firmware from now on. You print 80 column cards and then you put them in and update the firmware. Which isn't too bad because firmware's
Yeah.
not that big. You're always running out of room apparently.
Yeah, well, not bad. Not bad. I'm kind of wanting to make that 3D printer thing again. That would be because this is one of those projects that when I was thinking a lot about it, I didn't have nor the printer, not where to put them to print like for 3 days straight, nor the money to buy the filament. And now that I have all of it, that is not that difficult.
See you, Jim.
Yeah.
The
So
3D printer one was called the Molbot. It was red and blue. Thank you. Yep. The one I was talking about was the carbon fiber thread. Okay, sorry, I mixed the two streams. Don't cross the streams.
and cross the
The
street.
the Tom's
No,
video was the carbon fiber one, not the one that
no,
was fully 3D printed.
I haven't seen it, but I did the Melt Zone podcast with Stefan the other day when we met.
Yes, because you went
So
traveling.
my face should be there.
Okay.
3D Kastner asked if I'm going to use NEMA 23 motors. That's one of the options using NEMA 23. But I think one of the kind of my twist on this printer is being able to make it work with the. I'm not going to say the wrongest parts, but showing that you can do this kind of insane things with the least overkill components. Like what's the smallest motor that I can use for this? Because for the Z-axis, it doesn't matter if it is 400 millimeters, 300 millimeters, or 1 meter. It's going to be just a little bit more weight, but it doesn't move that often. So lifting the entire bridge is not that big of an issue. Moving the X carriage back and forth is going to require one, maybe two NEMA 17 motors, because I'm planning to go direct extrusion, because there is no way that I'm going to be able to pull off a bow that is kind of 2 meters long. That will require some heavy retraction. And for the Z-axis, I might need to go maybe with 4 NEMA 17, maybe 4 NEMA 23, but I think I will try first with NEMA 17. Just because I can. That's a very easy thing to swap if they are not powerful enough. And yeah. And Duet, the guys at Duet 3D are sending me not a Duet 3, but a Duet 2, because I was in a hurry. They offered me the Duet 3, but I had to wait for it to be available. So they are going to hook me up with a Duet 2 with an expansion board within the lot. And I think those can drive the NEMA 17s a much higher currents than the A4988 that I've been trying on the ramps that I've been using for my homemade or DIY made machines. So I think with NEMA 17 we are going to be good. Yes. 2 week sprints, but good. Yeah.
3D Guzna saying you should look at the White Knight 3D printer, which is the belt printer. I don't think that serves your needs based on what you've already described.
No. He will need to make an even larger version of his printer for me.
Yeah, because it's only like 300 wide or something.
Yeah, you can make it as long as you want.
As long as you want, yeah, sure.
And this printer will not have a 3D model. This one is going to be one of my on-the-fly projects. I will go straight to build.
Ah, yes.
And whenever I need a 3D printed part, I will design it and print it.
Yes, and if you need to tweak something, you'll pull out a drill and a hammer and a chisel and pliers and Bob's your uncle.
Yes. Yes.
And a screwdriver and spacers.
I don't want to be like 3 months making a 3D printer. I hope that I can finish it in 2 weeks, tops. So
how long?
2 weeks.
2 weeks.
Tops.
2 week build.
Yes.
Okay.
Yes. But not having to do a 3D model is going to accelerate things a lot.
Yeah.
And I'm going to be using parts from other printers. I'm just cheating my way.
Yeah. Cannibalizing.
This.
I understand. Frankenstein.
Yes.
Bye, Teresa. Good night.
Bye. So it's going to be bots over bots over bots.
Okay.
But I'm pretty confident. I'm 90% sure that it's going to work.
Yeah, as long as you can update the firmware with the dimensions, then that's. I understand mechanically you'll be able to build whatever.
Well, not whatever, but yeah. I'm kind of putting the twist on it, because if I wanted to go like crazy with this, I will go with maybe 45 extrusion, or maybe 90-45 extrusion, and go with linear rails and go with NEMA 23 motors both ways in every axis, that will be easy. And easy is it's not fun. I like the challenge. So yeah, so that gets the part of the electronics decided. RAM's point 3D RCNC says that RAM's 1.5 just blows up after 2 seconds. I've been using two homemade printers with RAM's 1.4s, good RAM one, the ones from Static Boards, which are it seems the fancy ones. Do you know them? JAYTEE is reading the chat.
Yeah, I got to read the chat.
Yeah, no, I was saying that the ones from Static Boards are good RAMs 1.4.
Oh, the question was for me about do I know them? No.
Yes.
I don't know them.
Yeah, there's. It might not seem like that, but there is no one in here that can reply to me by voice.
Yep.
Seems like I'm talking like behind you. So yeah, for me, RAMs 1.4 are very good boards, as long as they are built with some sort of quality. They work very well. They are very cheap and they are very easy to use, to configure and to wire and everything. So I like them. I like them a lot. There is thing called Smoothie Board that I know nothing about, and seems that there is a new one coming out soon. Something.
Also, SKR is that the right terminology? SKR, like 1.3E or something. That seems to be a fairly popular modification board for the Creality series. Inexpensive too.
Yeah.
But you can't run that many motors on the ramps. Okay.
3D Gassner says that Glenn. Who's Glenn?
Fun King 3D.
Oh, okay. Yeah. Like everybody can have an opinion, an experience, or being right about what's the best configuration for a 3D printer, based probably on the bed size and the lot. But that doesn't mean that other configurations are wrong. Like if you want to make a very narrow and very tall printer, you can do a Delta style printer. You can do that. That doesn't mean that others are wrong. That's not how this works. That's why you can see a 3D printer that has a bed of 200 by 200 by 200. See one that is Prusa style, other one that is Darwin style, other one that is Delta style, and all of them print well.
Mm-hmm.
Some of us have stronger points than the other ones, but that doesn't mean the rest are wrong. So yeah, you can run that many motors on a RAMs, not one. You can do that on 2, and you can use an extension board, and you can duplicate the drivers, and you can do lots of things. I'd say that. Using a RAMs, if you use a RAMs, it's because you are on a tight budget. You don't have that much money. And then I usually tend to consider that there is a trade. If you don't have that much money, then you have a little bit more time. Exceptions allowed. So you can, for example, if you have 8 motors on the Z axis, you can just get the signals from the pins for one of the Z-axis stepper motors, move them to another board, and just duplicate the signals. For example, if you use one of the CNC shields for an Arduino Mega, you can just wire the 4 drivers on that one to move the 4 Z-axis or Y-axis motors of a bed or anything. So there are many bots that can make you run many motors on a RAMs very cheaply.
Okay.
Did I explain myself, or I'm just ranting here?
No. You said in long term there is a solution, and it's not that difficult.
No, yeah. Sometimes it's time consuming, but wiring is that's right. Wiring is time consuming always. So yeah. And the moving mass, yes, it will be around maybe 6-7 kilos, bed going back and forth. Yes. But I don't see that as that big of an issue. Yeah. I will be proved wrong by myself with time if that's the case. So I'm not that worried. Yeah. And I don't know if any other electronics in this case. Uh, and the thing about the amount of motors, I think I could make it work with one single motor on the y-axis. That is not.
Sorry,
Come on, JT, come on. How late is it?
1 o'clock.
Well, 1 o'clock.
No, because we
I'm
just switched to
afraid.
summertime.
Really?
Yeah, yeah.
So,
And when
and
you
when I
change
switch
back,
to win,
yeah, when you switch back, it'll be 1 a.m. start for me.
really,
Mm-hmm.
we are
Dedication.
we will have to do this on my mornings. We will figure it out.
We'll figure it out.
Yeah. Yeah, I was saying that if you want to make that y-axis bed work with one single motor, you can do it. That is, you just have to put a very tiny pulley on the motor, like the 12 teeth that I used on the CNC machine. With that, you can move almost anything. And you can even use one of those with a 5 to 1 gear motor, and you will be even better. But the thing is that it will be very slow. So everything in this kind of design is usually a trade-off. You can trade price by stiffness. You can trade number of motors for speed. There are a lot of trade-offs. But there is no wrong way of doing it. But there is almost no wrong way of doing it, because you can.
You can compensate for one, it, it, but you can't have everything. You can't have
Yeah.
speed and stability and um,
Now, if you want to have a y-axis bed that is extremely fast, it's not only a matter of, for example, being able to move it with one motor. The mechanical part of it has to be stiff enough, so when you try to break the bed, the bed doesn't want to tilt. And for example, if you want to do that, there is many cases and many first the first batch of 3D printers that came from China had many mistakes that could have been solved for no money at all, with no cost. For example, if you are attaching if you have a bed that moves back and forth, and you have a belt on it that goes behind it, moving the entire bed attached to the bed, you have to put that belt as close as possible of the center of gravity of the bed, and even a little bit higher, counting that sometimes it's going to have even more weight on top of it when you are printing something. So no torque is applied to the bed when you are trying to accelerate it. That way you are not putting strain on the mechanical components, and they don't get some sort of play with time, which never happens when you are designing a 3D printer in 1 month. So yeah, but those are decisions that take no money. They have no cost. You have to decide where you put the connection between the belt and the bed, and that's just not knowing what you are doing. So yeah, the bed is moving slow anyway. You can just use lead screws instead of belts. That will be insanely slow. Like you will be talking like with a belt, you can be talking about millimeters per minute. With a screw, you can be talking about
millimeters per hour.
Yeah, that's insane. No. Because with screws, you cannot even see the movement. And I'm not talking about it being slow top speed wise. I'm talking that it's going to be slow to accelerate, but the top speed is going to be almost the same. The only thing is that when you say to your slicer, what are your acceleration figures, you will have to put them slow. And when you are talking about jerk, like the bed doing like you will not be able to do that. You will have to do that, but very slowly.
Okay. So.
But I have the advantage of knowing what is going to be 3D printed on the machine.
This was going to be one of my questions. You already know what's happening, which
Yes.
Which helps in the mental design process of what's happening.
Yeah, it's very important.
How many sets of V-slot wheels will you have under this monster bed? 3,
I'm thinking
4?
about having. I'm thinking about having maybe 4 sets of 4V wheels.
Yep.
Yeah, or maybe between 4 and 6, 2 to 3 rails just for that.
So 3 rails, front and back, quad.
Yes.
Yep.
Yes, and having I will have a smaller platform. Is the platform in which the bed is fixed and will be level is not going to be like if you see a CR10, there is an underplate that is smaller than the bed, and then the bed sits in top of it, and that has a very good reasoning. Is because if you have a bed that is an undercarriage that is the same size as the bed, if your bed moves back and forth 1 meter, for example, you need 2 meters of underplate and 2 meters of linear guides or V-slot profiles or whatever you have below.
Yep.
If you have, for example, for a 1 meter by 1 meter, a 600 by 600 undercarriage, you only need 12 millimeter, 600 by 1 meter, 1.6 meters of travel. You will always need the travel of at least one bed dimension in
Yes.
the y-axis, but you have to add that basically that dimension of your undercarriage. So
Okay.
the smaller it is, the less size you need for your bed.
And so you've got to find the balance between the size
If
or
it
the minimal
if it is
size.
too small, it will tip.
Exactly. Yeah,
Basically,
that's what I was about
everything
to say.
will bend.
Yeah. Okay.
Yeah. But I think 600 by 600 millimeters is a big enough undercarriage with 2 millimeters, 200 millimeters of back and forth, back and forth.
Yep. What was that?
Something
See ya.
something
Yeah,
fell.
that's a spool. Uh-oh. Go take a proper look.
Yeah. I have no idea what is it. Meh, don't worry.
Okay.
I,
Uh,
I will take a look later.
that was his 3-week print falling off the bed.
There is nothing that long going
Yeah, I understand.
now. No. So yeah. When me,
He almost bought a 1 meter cubed printer when he got his resin printer instead.
that's insane.
Yeah.
Yeah, I cannot because there are some companies that are selling that kind of huge machines, FDM huge machines. But if it is not for a very specific, come on, JT, we are losing you.
No, we're good. We got 8 minutes to go, and then we'll chat for an hour.
Okay, but yeah. What I was talking about. I was talking about the 1 meter by 1 meter by 1 meter. Yeah, there are companies that sell those, but those have to be for a very specific purpose. Like those cannot be for general part printing because that is insane.
Yeah.
And those take ages to print even with large nozzles. So.
This was another question that I had. So even if you're printing at 0.2, will you use a standard 0.4 nozzle, or is there an advantage using a bigger nozzle and still printing 0.2?
There is an advantage. I will at least go 0.8.
Yep.
And keep the 0.2 layer height because
Hi,
I
Mia.
don't want to grow old watching the thing print.
Yeah. Okay. So you'll get more speed.
You get more speed because you can put more material on the part, and you get stronger parts. Because you get the wall whenever you are making a wall, you get a much wider wall. If you go with a 0.8 nozzle and a 0.2 layer height, and you ask it to make a 0.8 wall,
yes.
If you do a 3 outer layers, for example, you get a 2.1 millimeter wall that is only 3 layers thick.
I hadn't considered
So it's very
that. I hadn't
thick.
considered that it wasn't a cylinder.
It is not a cylinder.
The extruded part is not a cylinder because.
Oh no.
Right. Okay. So I can see benefits.
You get. I can do this now.
Oh, we're mobile. Yes. Oop. Whiteboard. Yep. There we go.
Let me see if I can see what I can print. I can do it here. Like if you are looking at it from the top, a regular pass of the regular pointed 0.4 nozzle and a 0.4 wall would be this. The same path made by a 0.8 nozzle would be something like this.
Yes.
But seeing from the side, this one will be this, and this one will be exactly.
You're off camera. Tilt the camera upwards or down below.
Yes.
Yep, good. So that's still the same.
Like,
yeah. Okay.
Yeah.
And the
So
slicer the slicer understands um, the mathematics of the nozzle
yeah,
size.
if you go to the slicer, for example, simplify. Let me exit preview mode. You say which extrusion width you want, and you can set it to manual or you can set it to auto. So if you go with auto, it will decide what is the best width for the uh, what is the best width for the other two settings that you set up. And also in layer, you can set the layer height that are derived from the primary layer height.
Okay.
So you can say the primary layer height 0.2, and the rest of the layers with 100% of that one. So everything is zero point 0.2, and set that the extrusion width will be 0.8 or 1 even. If you say that it is going to be 1, for example, the slicer will have a hard time knowing how much it has to apply the extrusion multiplier. So it can squeeze much wider than the hole that is below the nozzle.
Yep.
So
Yep.
that can get tricky. But even that, if it is well tuned, you can get a pretty decent result.
Okay.
So,
Good.
and depends on material. You can maybe, if you are printing with PLA, you can even go a little bit hotter and try to like squeeze more material out. It's kind of finicky. I'm using Simplify 3D, not because I like it the most, but because it is the one that I'm using. It's kind of, yeah,
It
it's
works
the
for
one that
it
works.
works for you. Yeah.
Works.
G'day, Brian
Yeah.
Locke. How are you?
Hey.
Yes, it was. I reckon it was a rabbit. I played Destiny, and there's a weapon called the Jade Rabbit, and that's the sort of icon on the weapon. You're drawing, Ivan, on the whiteboard.
Oh, okay.
Looks like a rabbit. There was some important debate about rabbit or cat. Here we go. He's doing the art class, and then he's going to spin the camera after he's perfected.
No, it's pretty shitty
Terrible.
drawing.
Okay, shitty rabbit. Oh, now it's what's the SpongeBob crab or something with the funny eyeballs? Wellbot will know the answer to
Wellbot
that.
knows.
Yeah, yeah.
Wellbot knows.
Or Mia would know.
Yeah, yeah. So yeah, yeah. Well, I think for today
Mr.
we
Krabs,
have
thank you.
said, yeah, Mr. Kraft. I think we've said enough potentially wrong things today, so we can like leave it now.
All right, so we'll do a
Like,
part two next week. Shall we? Shall we put some questions on Twitter, or I'll organise a hashtag or something?
I think we can ask everyone to recommend us DIY 3D printers,
Okay.
especially the ones that are not standard, like not a CR10 clone, but weirder, like the one that David made. Yeah.
Okay.
Yeah.
So you're
Recommend us your weird
yeah.
printers.
Tell
Yeah.
us. So you probably all know me, JAYTEE at you. Boop. Hit me up on Twitter, with your ideas of customized 3D printers, and yeah, we'll add it to the list for next week.
Yes. Well,
Very good.
have a nice week.
Yes, thank you all, and we'll see you next week. Bye
Bye.
bye. I'll do the intro properly this time.